Well, hi everybody, dear colleagues, ladies and gentlemen. I am Mišković, Associate Professor at the Faculty of Mechanical Engineering at the University of Belgrade, and I will present you our paper titled The Risk Assessment of 3D Printing FDM Technology. At the beginning, I would like to answer the question, why this topic? As we are all aware, additive manufacturing technologies or 3D printing is nowadays used in almost all areas of science and technology. As you can see on these examples over here, it's used in construction engineering, it's used in medicine, it's used even for food production, and it's also used in everyday life by regular people without some required specific technical education. Here you can see some illustration of what is 3D printing used for. As you can see on this pie chart, it's used mostly for rapid prototyping, but also for production of some spare parts, etc. It is estimated that in the year 2026, the total market value of 3D printing technologies and related products will exceed $44.5 billion. And you can see forecast of this diagram here according to different research presented in the upper left corner. And here you can see expectation from 3D printing in history. As you can see, there was a very high increase in expectation around 2010. After that, suddenly drop out. But after 2014 or 15, the expectation from 3D printing technologies are getting higher and higher. Most widely used 3D printing technologies are those presented on this diagram. And of course, all these different 3D printing technologies will focus on the FDM 3D printing technology because it's most widely used as a home and office 3D printers. And as you can see, the most used materials for FDM 3D printing are ABS and PLA. The principle of FDM or fused deposition modeling 3D printing technology is, as you can see, well, the filament is inserted through a tube, through an extruder, and it melts and it forms layer by layer 3D printed objects according to the CAD pattern. So when we researched the literature, we found out that only few references are dealing with the risk assessment of the 3D printing technology, especially FDM. You can see two of those references. One is published by Denmark Environmental Agency, and the second one is paper dealing with the risk assessment of fumes produced during 3D printing. So we can conclude that FDM risk assessment is not performed at the adequate level. The object of our risk assessment is this 3D printer, which is shown on this slide here. It's called Prusa Mini Plus because it was selected as one of the best 3D printers for home use in 2023. Its price is roughly $400, but it's very precise. It can use PLA and ABS 3D printing materials, among other, but these two materials are most widely used. ABS is a material that delivers mechanical stability and resistance over time. And as you can see, Lego cubes are mostly made of ABS plastic, and PLA is fairly strong material, but less flexible than ABS, and it's biodegradable. And it's also very widely used for 3D printing in homes and offices. And now you can see different methods for risk assessment. For example, what-if analysis, failure tree analysis, etc. But among these risk assessment methods, we selected KINNEY method as most appropriate because it's widely used in mechanical engineering. and it's one of the risk matrix approach methods. KINNEY method is described here. As you can see, risk level is calculated by multiplying of probability, consequences, and frequency of some hazardous event, of some hazard. And in the lower part of the slide, you can see guidelines for assessment of probability, of frequency, and of consequences. But first step is to identify the hazards which are present during 3D printing by FDM technology. And for that purpose, we've used international standard and ISO 12100 from 2010. And in that standard, you can find the list of potential hazards, which are divided in several groups. And here I have to mention that we didn't analyze environmental hazards because they depend on the working place, on the working conditions, which depends on the usage of the 3D printing, of the 3D printer, sorry. So we identified the following mechanical hazards. First of all, there are a few moving elements, printing heads. Then there are some rotating elements on the upper part of 3D printer. And also there are some sharp objects present. First of all, as some part of 3D printers are very sharp, but also printed objects could be very sharp. Second type of hazards are electrical hazards. As you can see, there are some parts which become alive under faulty conditions due to bad insulation. At least on 3 places and under the heating table. Third group of hazards are thermal hazards. As you can see, there are 2 spots on the 3D printer which are extremely hot. First of all, printing head, which is shown on the left side, and also printing table. We also identified different material substance hazards, especially due to fumes or vapors produced during the 3D printing as a result of filament melting process. And you can see here that also PLA and ABS has a lot of different vapors coming out of them during the melting, for example, formaldehyde, acetaldehyde, and so on and so on. And beside those fumes and vapors, also fine dust particles are produced during 3D printing, which can be also hazardous for health of the man operating the 3D printing. Regarding the ergonomical hazards, we identified 2. First one is effort, because 3D printing process lasts very long. For example, as an illustration on the right side of the slide, you can see that printing of the 1 hand size object can last for 34 hours, which also causes the mental overload because worker, the person who operates 3D printer, needs to be focused to control this 3D printing process at all time and so on. So it could be very tiresome. And based on these identified hazards and based on those guidelines for risk assessment according to KINNEY method, we performed the risk quantification. For example, the hazard due to moving parts, which cause mechanical hazard. For example, it has frequency, it's regular occurrence, the probability that moving elements will appear during 3D process is 10 maximal because it's part of the process, and consequence is low because moving parts from 3D printer cannot hurt someone so much. But risk level, which is obtained by multiplying those quantified parameters, equals 100, which corresponds to high risk level. And also, we have only one low level, That's from electrical hazards. And some medium risk level is due to sharp object hazards. Because also 3D printed objects are not very large in volume, so they're small and they cannot make a huge consequence, and their probability is medium, let's say. And for those identified hazards, we prescribe some safety measures. First, we recommend that checklists should be used before 3D printing process on daily basis. This is one example for machine guarding checklist, and before 3D printing starts, the operator should check if everything is correct. This is only one example of checklist. Also, we recommend that during 3D printing, safety equipment should be worn. Safety mask in order to reduce the number of dust particles inhaled and reduce the vapor and so on. Safety gloves, safety glasses, lab coat, and also different filters. Third safety measures are environmental measures. We can recommend that during 3D printing, enclosures should be used, like in this example on the right side, and also ventilation to capture chemical emissions, like in the example on the left side. And final safety measures are organizational measures. The time spent near the printer should be reduced in some way. For example, if you decrease the working time of operator, and also workers should be trained on potential hazards and how to protect themselves. And this diagram on the right side is very interesting because it shows average number of working hours per week in the year of 2016. And there are no data about Serbia because we don't work. And as a conclusion, risk reduction of use deposition model in 3D printing will save the money for the employer and also save the health of the employee. And that's the point of papers like this. And you will find a lot of more information in our final paper. This is only a brief presentation. Thank you for your attention. If there are some questions, I would like to answer them.